Hello, I am Domenico Cipriani, and now today I'm going to present you Phausto, that is the sound within Pharo. And first of all, I want to thank the ESUG board and organizer and everybody that puts up this conference, because I really like it and I learn a lot of things and get to know a lot of people. And also Phausto, born in Lyon at last ESUG, because with Stefan and Guichet and Nawel we get in touch with the people of Graham, that are people making Faust, and we plug the things together. So thanks to ESUG, and thanks to Pharo Association for supporting me in this project. Okay. So what is Phausto? Phausto is a multi-platform library and API that enables programming DSPs, digital signal processors, and to do sound generation in Pharo. Just a question, how many of you have ever thought I would need sound inside Pharo? Quite a few. So Phausto is born for you, so the people that want to put sound inside Pharo, and is born for me, that I want to use Pharo to make not only the performance or the composition as I've done in the last years, but also the sound without using an external program. Like the first year at the in Novi Sad, I was using Kima. The last year I was using Super Collider, but then I thought, why we can do it all in Pharo? And so it's for me, but it's also to beginners and to musicians that want to program DSP and audio. It is very, very complicated to program audio, and I think that with Phausto and Pharo it can be easier to teach and to learn and to do. So this is also for sound artists and for beginner developers. I think this can bring more people into Pharo and into Smalltalk, because like I was brought by Kima. So we have this, the audio is generated through FFI calls to a dynamic engine that was made by the people of Faust. We will talk about Faust later. That is basically an embedded Faust compiler. So there is a Faust program that is computing the audio samples and feeds that to a port audio. That is another library for audio, is a multi-platform library. And we choose to use port audio because it goes with Mac, it goes with Linux, it goes with Windows, everywhere, and it's very light. And Phausto is very light because all the libraries that you need to download is just around 9 megabytes. So there was this thing about being portable and being lightweight. I didn't want to have a library that is very heavy. Tomorrow I will talk about the implementation details at the IWST paper session at 11. So if somebody is interested in that, we will talk about that later. Also, I will compete for the Tech Awards, so I will show you more in details how it works and how you can integrate Phausto in your Pharo application, Pharo programs, okay? Why I choose Faust? Faust is a functional programming language for sound synthesis and audio processing that is created at Graham in Lyon. So we have 100% French technology, how some people like to say, made by an Italian. So the Italian people doesn't hate French, like many think, but not, not everybody, maybe. And Faust is considered the state of the art in the research and development of algorithms, so of virtual analog synthesizer, filters, waveguide. They have done a lot of work with a lot of people, and so there is an extensive library that we can use inside Phausto. This is called Faust Standard Libraries, and we have a lot. We will see what we have in Faust already, but if we can take a look, for example, at the page of Faust, for example, I don't know if you are familiar with physical models of instruments, but physical models is a way to synthesize strings and bowed instrument and tube and percussion. And here with the library of Faust, you have everything like guitar, strings, clarinet, violins, flutes, marimba, djembe, whatever you want is ready to go. Also, you have a lot of effects like reverbs, for example, that they are very good and they sound very good, and they are very difficult to implement well. So the idea is that you and the sound artist can use these reverbs that are the state of the art, and they are ready to use and ready to plug. Then if you want, you can design your own, also with Phausto. So you have the two choices. If you want to stay low level, if you want to stay high level, you have almost everything. Okay. So all the concept about Phausto, of writing of the API of Phausto, we say, is centered around the unit generators. The unit generators are the basic building blocks of signal processing, so you can think about like oscillators or filters, and you plug them together. The first one to develop this concept was Max Matthews, that gives names to the famous program Max MSP. I don't know if anybody knows Max MSP, but it comes from Max Matthews. That is like a pioneer of computer music. Okay, and the way how Phausto organize and implement these the function that are in Faust, because Faust is a functional language, so we don't have classes, we don't have objects, we have just functions. Okay, but how they are organized in Phausto are deeply inspired by the Chuck programming language, that is a programming language developed created by Gay Wang and Perry Cook back in 2003, and is still used, and is still like the state of the art still of like programming music. They say on the fly. They were the first to introduce this concept of programming music on the fly, so write the programs of audio while they are doing being done. So to install Phausto, you have this code. There is the GitHub repo, and you have to download the package, the libraries bundle for your platform, and place it next to your Pharo image. Inside this folder, there are free libraries. There is the dynamic engine. And thanks to Stefan Zlet's Faust to do the dynamic engine, the C part for us, and to help with that at any time. Then you have libfaust, that is the library that is computing the Faust program. And then you have this port audio that maybe you can have if you have Linux, or you cannot have if you have Windows or Mac, but just that. And Phausto works on Pharo 12, 11, 10. I didn't test it on 9, but maybe it works also on 9. Okay. So the approach of Phausto is inspired by modular synthesizer, where you patch cable together, okay, and you put just a generator to another generator, and then to a final output, like in the diagram there. And again, I borrowed this Chuck operator, this binary operator, to connect the unit generator in Phausto. I talked with the Chuck people. They were happy to contaminate the language with their operator, and it's a little bit of a tribute to them. Okay, so now I think we can go to some sounds. Today we will listen to the sound a little bit basically, but Wednesday we will listen it better. I have to turn it on. Yeah, you can listen to it. It's not so interesting. Okay. 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 So you very basic. This is the hello world. You just what you do is you create a DSP from. Here is just an object. It's a square oscillator new. Create an object, an instance of the class square oscillator, and you send a message as DSP. Then it becomes a DSP program inside Phausto. Then you initialize the DSP. It means that you are telling to dynamic engine to connect the Phausto program to port audio, so to the audio interface layer. Then it's ready to go. You can start it, and then you can stop it. And it would be better if you destroy it. I put many safeguards to destroy that. But if you don't destroy it, and I don't destroy it, but I hope that I am destroying everything. Otherwise, you are dangling pointers. So it's not Pharo fault. It's Faust fault. I'm sorry, but it's like that. So you have to do like that. It is always better if you take care of destroying it. Okay. So now we can go back to here. And for example, no, we can go back to Faust, and we can look at something more interesting. So now you see we have this sine oscillator, and I ported many of the function of the standard libraries to Phausto. The main goal is to have everything. Now we have like basic oscillator, reverbs, delays, some physical models, and all of them, they come like when you ask like sine oscillator new, they come with default variables. And this is something very different from Faust, because in Faust you don't have like default variables, and you have all the time, if you have a function with like 6, 7 parameters, you have to give all the 7 parameters, and you have to write a lot of code, even if you want just to change something. Like here, for example, the sine oscillator, it has a variable that is frequency, and you have a method to change the frequency. What happens? Let's say that you have first to write the DSP, and then you initialize, and then you start. So the architecture, let's say, of the DSP is before a compilation, okay? You cannot change the architecture on the fly, and this is not possible, not in Super Collider, not in Chuck, not anywhere, no, MaxMSP, Faust. You have always to rerun your program. What we can do here in Phausto, like in Chuck, we can have multiple threads, so we can have many DSP running at the same time, and that is the appearance of writing things more in real time. So here, for example, we have this. We initialize it. We start it. It's more fun. And with the help of Enzo and Janesh, they wrote some beautiful sliders with Toplo that you can use with Phausto. And for example, you can open these knobs for all the parameters you have in a DSP. With this beautiful knob, very modern, and you can. No? Ah. Okay. Okay. So you can also control your DSP with knobs. You have this nice set of knobs that get incrementing, and the idea is also that so a musician can use this Phausto for a performance, and you are not forced. Now we get to another example. Let's go here. Let's copy and paste this one. Okay, so here we have two pulses that are again elements of the Phausto standard library. So it's a pulse generator that is generated at one period. The second pulse is generated at a fixed period. The first one is modulated by a triangular LFO that is changing its frequency by the time. You see the LFO as like methods to set the is frequency, is offset, so and amount. And this is again something that is really helpful. All the APIs thought to be very helpful both for sound artists and for people that doesn't know too much about DSP, and to make everything more practice instead of getting things complicated. Because usually, I don't know, for example, with Chuck or with Faust, you will have the LFO, then you will multiply the LFO for a value, and then you add a value to have this offset and amount. Here you can see it, okay? Then we make a djembe that is triggered by the first pulse, and then we initialize the marimba frequency. The marimba frequency is changed with an LFO random that is changing its value at random time, and it has also an offset and an amount. And then we say that the marimba is triggered by the second pulse, and that's the frequency that is initialized to marimba frec. and with the addition, with the sum operator, we sum unit generator. So if we have like 10 unit generators, we just sum them together. And then here we have this practical word that is stereo, that makes the signal stereo. That's why, because in Faust, everything is mono. And you have to convert in stereo, and it's quite not too much complicated, but it's a little bit of hassle. Here you can just, with a keyword stereo, you convert it to stereo, or with mono, you convert something stereo in mono. Then we can initialize it, and then we can play it. No. Sorry. It was a set. I have to create the DSP, and then initialize it. Okay. So this is very basic example, but you have more stuff with that. Yeah, let's go back here. Again, we can open. We have basic morphic slider that are kind of not so good to see, but you can use them in Phausto without having to have Toplo on your Pharo, but better if you have Toplo. Like we have this example. Again, let's take here. It's stopped, I think. Yeah. I didn't stop because I'm a little bit like a squirrel. Because when you create a DSP, actually, it's destroying the past DSP. So I'm doing that, and I'm confident about this. So what is in the code when you say as DSP, it's checking, is there an active DSP? Yes, I destroy it. And it's working. But I always suggest to destroy it if you want to not have, if you want to be sure 100%. Okay. So we try. Here we have a jumbe like before with a trigger that is just a push, very boring, but it's going into a gray hole that is a big reverb with a very nice sound. And we initialize, we start. Okay. I wanted to show that if I open, I have this method that you send to a IC dark knob. That is, they are these knobs that are made by Yannis and Enzo, and you can open for all the parameters inside the DSP. Okay, so you don't have to worry about anything. You have. So it's very useful when you have a lot of parameters. You don't have to worry. So what happens? We'll see a little bit more tomorrow. But all. So what happens? We say that we have to define, let's say, before compilation, the DSP. How we change the parameters in a Phausto DSP? We have to declare is parameters as UI elements. This is how they do it in Faust. So in Faust, you have to declare a slider, even if you don't want to use it, but to control it in real time, you have to declare it. So what I did in Fausto is that all the parameters are already declared for you as a UI parameter. And with which name? With the name of the parameter, and as a prefix, they have the name of the class. So you said all the parameters of gray hole will be a gray hole dump time, gray hole decay time, and so on. If you want to change the name because you want to have free gray hole reverb, you just change the name, and the parameters will have a different name. And I think also this is very practical because, like in Faust, if you want to have the control like of 20 parameters, you have to write 20 parameters with the constructor of the slider. That is a very long function with label and initialized value and minimum and maximum, so it's a little bit not so funny. Okay, yeah, so this again is a syntax. So the syntax we we connect the unit generators. How you connect the unit generators? The unit generators, like they come with some kind of definition how they are connected together. So, for example, you can connect a oscillator to an envelope, and it knows that it will be multiplied. You don't have to. You can do the multiplication by yourself, but if you just plug them, they are doing multiplied. And when you are plugging this synthesizer to the reverb, then the chuck operator is taking care of feeding the inputs of the reverb with the sound that you have. So you don't have to worry too much about how the sound have to be constructed, because they are constructed by themselves. And if you try to plug two unit generators that can't be plugged together, you just get a debugger that say to you, you can plug this with that. Okay. And then you make the stereo DSP, you initialize, you start it, you can trace all the parameters if you want to control which parameters we give it to you. And then you set the value of the parameter with set value parameter. Okay, so we will say later who is interested in putting Phausto inside his Pharo program. This is the key access to changing the parameter of a sound. It's just there. And if you want to trick a sound, you just say to the DSP that you want to trick that parameter. Okay, so like playing a note. Okay, this is a little bit about the implementation of the chuck operator that is just calling that chuck into. So you have the chuck operator that is binary, is calling the chuck into a box, because the unit generator are all boxes. We see it tomorrow. And then by double dispatch, every is a box patched with self. So it depends on which unit generators is going. And every unit generation take care of what is happening with the chuck operator. So I think it's good. And yes. So more things. There is also this thing that is called the toolkit, that is inspired by Perry Cook and Gary Scavone standard toolkit, that is a little bit of a collection of sound generators for audio programmers. This is intended both for audio programmers and for sound artists. And you have delay with feedbacks, and you have incrementer, resetter. You have all this stuff that is not into the Faust standard library, but that I thought that will be useful to not write, because it's a little bit long to write, and you have to know a little bit of Faust, so it's better to have a delay is there, you have it, or a basic sample player. And then you have this TurboPhausto. We don't have the example yet, but it's for to go with Koipu, and that is the package for programming music on the fly. And on the performance of Wednesday, you will see five synthesizer of TurboPhausto that are for to go with Koipu. So it's for live coders that doesn't have to think about how it is implemented, but just use it with Koipu. Okay. So now let's see if this works. Hello. Okay. For example, I have this. I don't have to talk now, because I have just to open this turbo transcript. Let's see if it works. Okay, so you open this turbo transcript and you say bon appetit. That, given the time, works. But is easy, like you. Okay. Very bon appetit. Yeah, you can use it like for error messages or something like that, or you can also make your application more sustainable, because you can give sounds or even talk, so putting like description of what is happening with audio samples. Or there is also a vocal synth in Faust that I hope in the time will be ready to use also in Phausto, so you will have like this mechanical voice that tell you, you open the transcript, okay, something like that. And basically, in this subclass of the transcript, what I'm doing is just using a sample player that is also from the toolkit, so it's something for programmers to have an easy way to open a file, an audio file just with a path. We have the path to the first. We locate where it is my samples, and then I locate the sound itself. I give it a name just to control it, and then I just initialize the DSP. I create the DSP, initialize the start, and then when it open, it plays the sound. Okay, this is very, very simple example. If you need more sounds for your application, you have to describe to make a big DSP with all the things you need. Think, for example, if you need like in Ronnie, and you want to put sound, so maybe you have the good thing is that you have access to all these physical libraries of Faust, so you can like have objects of different materials that are falling from different aids, for example, and then maybe you can have on your DSP you can have an object that is metal, another that is wooden, and the other that is paper, you know, and the noise of the ambience. So you can do very complex stuff and initialize it with when you need it in your application. Okay, and then we are finishing. I want to show you an example of algorithmic composition, because now we have Phausto, and you can also make composition just using Pharo syntax. You can use Koipu if you want more like a live coding API and library, but if you want just to use Pharo, I should have the example here. Yeah. Okay. So, for example, here I create a DSP that is just a PSG Plus. That is nothing to do with Paris Saint-Germain, but is an emulation of the PSG sound chip that was used in Sega Master System. So a very basic oscillator with 3 waveforms, and it's going to a delay to make it a little bit more space. And then so we initialize it, we create it, we initialize it, we start it, we don't hear anything. So what we are doing here, we're just asking all the subclasses of collection, and then we say, okay, let's play a different note for the size of the selectors of every subclass. So you have all the subclasses, and we can hear how they sound. Let's see. We have using this play note that is just like playing a note for us of the DSP. We have to tell the method which is the prefix of the synthesizer, and we say a duration in seconds, and then we just use a delay to go from one note to the other. So basically the composition in Pharo, if you don't use anything else, is just sending playing notes, changing parameters, triggering sound, and make a delay advance in time. Let's see how it goes. So this is the sound of the selector size of the collection. You can make it a little bit prettier. You can use more, go more inside the code, but this is called like sonification. So we can sonification, until now we can visualize the classes, subclasses, methods, all stuff. Now we can also sonify that, and maybe you can go to a conference of music audio programmers and show the sonification of Pharo classes. Did
you link it to Russell?
To Russell? I did some tests. I did something. It's not here because I lost the image. My fault. So it's not here. But I made something with both with Russell and with Block. I have something with Block if we have time, or maybe we'll show you later. Just pressing and making a sound. Yeah, what we want to do in the future is to implement all the standard library function in the Faust standard libraries that are more than 240. Now we have like 40, 50. Okay. Support for external MIDI input. It means that you plug a MIDI keyboard or a controller and you play your Phausto sound, because now is everything about code and UI. It's a little bit like, from a musician point of view, can be a little bit Extend the toolkit, design a basic set of instruments with TurboPhausto, so we have this like live coding, programming of music on the fly suite that you can use for everything, and implement a robust and modern UI with Toplo. So who doesn't want to use code can use a UI and have his synthesizer. And thanks for our association. Thank you for listening. This is Simone.
We can ask a couple of questions if there are. Does someone has a question?
Sorry, this is not a sound question, but regarding the finalize, the destroy,
Yeah.
the manual, did you consider maybe hooking into the GC and automatically destroying on the finalize action or something like that? I don't know. I mean, I agree on having an explicit destroy and telling the users to do it, but as a fallback.
Now I'm telling the user to do it if you want to be safe. It should be safe anyway, because I'm trying and I don't have problems now after a lot of time, because there are a lot of things that has to be checked. So there will be a point that we can say forget about destroying the DSP, and like that. You're welcome.